Welcome, welcome, welcome to chemistry, Miss Lisa's chemistry channel. This is section 2, and I know you're like, why am I looking at the corner of the room? It's because my phone today keeps going to the wrong orientation, and I want it to know that I want it to go this way, because this is the calculator part where I'm going to show you how to do the math, and I want it oriented this way, but the phone keeps trying to flip it, and even if it flips it, I guess I'll be okay. So this is our math lab part of chemistry, chapter 4, where we're going to talk about how to do these problems on our calculator. So this is, we're working our way through this Addison Wesley chemistry book, and please ignore my phone dinging over there. Now it's through. And what we're going to do is we're going to talk about these different problems, okay? So our first problem, it says, it wants to know, it says the element nitrogen has atomic number of 7. How many protons and electrons does it have? Well, this actually, we don't have to use our calculator. This is really a definition thing. And it's that the atomic number is the number of protons. So the number of protons would be 7, because that's the atomic number. And if the atom is neutral, meaning it has not gained or lost any electrons, it's not an ion, it does not have a charge, then the number of electrons will also be 7. That one was easy, wasn't it? Oh, I gotta move my calculator to turn the page here. All right, so let's do example number 2. All right, so this is a very typical chemistry problem. We have 3 different elements here, and they tell us their atomic number, and they tell us their mass number. Okay, now this is different than the mass number on the periodic table. The mass number on the periodic table is an average mass, and this is the mass of a certain specific isotope. So if that doesn't make sense, it will the more you learn chemistry. All right, so we're told these 3 elements, beryllium, neon, and sodium. Beryllium has an atomic number of 4 and a mass number of 9. Neon has an atomic number of 10 and a mass number of 20. And sodium has an atomic number of 11 and a mass number of 23. And they want us to tell how many protons, neutrons, and electrons are present. Well, we already know the atomic number is the same as the protons. So we could just write that down, 4, 10, and 11. And these don't have any charges on them. There's no little pluses and minuses. So we know that the electrons are also going to be the same thing. Now, how do we get the neutrons? How you get the neutrons is you subtract. It is the mass number minus the atomic number equals the number of neutrons. So 9 minus 4 is 5. 20 minus 10 is 10, and 23 minus 11 is 12, right? Yep, that works. All right, so that's how you do those. That's pretty easy. We didn't even have to use our calculator. Okay, the next one is we are given this symbolism, and what does this mean? This letter O means this is oxygen. Oxygen has 8 protons, so its atomic number is 8. And this isotope of oxygen has a mass of 16. So we're supposed to say how many neutrons does this have? Well, it's 16 minus 8 is 8 neutrons. So that's our neutrons. This one is 32 minus 16. And you don't have to do these in your head. You got a calculator, so it's fine to use it. 32 minus 16. I know this one in my head, but not all of them. So you can see that it is 16. This one is 108 minus 47. That's a good one to do on your calculator. Now, what I always tell my kids about calculators is if you miss a problem in chemistry, I want it to be because you didn't know the chemistry, not because you tried to do math in your head and got it wrong. You pay a lot for these calculators, so I say use them. Even if it's something simple that you should be able to do in your head, then you need to use your calculator anyway. Your calculator doesn't freeze up. Your calculator didn't stay up too late playing a video game or talking or texting your friend. So your calculator won't make dumb math mistakes, but you can. So for each one of those, all I did was subtract the protons from the mass, and that gave me the number of neutrons. All right, let's do another problem. That one was fun. Okay, here's the next one. We are told in this problem that there are two isotopes of carbon, carbon-12 and carbon-13. They're both carbon. They both have 6 protons, but one has 1 more neutron than the other one. It says, give the chemical symbol for both. So how you write these chemical symbols is the atomic number goes on the bottom, the mass number goes on top. That was very easy. This is going to be an easy test, isn't it? Okay, here, let's turn the page. Okay, now, so this one says copper has 2 isotopes, copper-63 and copper-65. Given that the atomic mass of copper from the periodic table, and remember I told you that's an average mass, is 63.54, which is more abundant? Well, the answer is, which one is this number closer to? And this number is closer to 63 than 65. It's only a half away from 63, but it's quite a bit more than that from 65. So the answer is copper-63. It's whichever one is closer. So that was easy too. Now, this is another problem, and this one is that you have 2 isotopes of an element. Okay, and one of them has a mass of 10 and one has a mass of 11. One has an abundance of 19.91%. The other one has an abundance of 80.09. Is that what it says? Yeah, 80.09%. So how do you get the average mass from this? What you do is you multiply them. Now, first, remember, if something is a percent, you first have to change it into a decimal before you multiply. And how you do that is you move the decimal point 2 places over here. So this is going to become 0.1998 or whatever that says. I wrote it in green on blue, and I thought I could read that. No, I can't. Okay, so then we take this mass and multiply it times this one, and we move the decimal point over 2 places. So our first one, let's do it on our calculator. Let's see if I can do it. I'm going to clear out what's in there, and I'm going to put in 10.012 times 0.1991. And I get that big old long number, but I round it off to 1.993. I do the same thing with the second one. Then I draw a line just like in 3rd grade, put a plus sign and add them up. And the answer is 10.810. And the unit for masses on the periodic table is AMU. It stands for atomic mass unit, which I think is sort of unimaginative. All right, so that's all the math. Probably the hardest thing is that last problem, and that's not very hard, and you'll do it on your calculator. So do all your homework, and science is great, and math is great. Come back next time, like, share, subscribe, and I'll see you later.